In this recording, we will discuss circuits that include resistors that are in series, resistors or light bulbs that are in series. Just a few reminders before getting into that. What we define as current is the number of charges or the amount of charge that passes a particular point per second. The unit is coulomb per second. It's called amps, and the symbol for current that we use is I. What we define as voltage is electrical potential energy per unit charge. It is joules per coulomb, which is called volts as a unit, and the symbol is V. Electrical power is the product of the voltage and the current. P is V times I. For a resistor, it is also equal to V squared over R, or it is also equal to Ri squared. The symbol for power is P, and the unit is watt. What we define as resistance, it is a quantity that depends on the length of the wire and its cross-sectional area, and the material the wire is made up of. So R is equal to rho L over A. It depends on temperature. It increases when the temperature increases. It is also related to the voltage and the current through Ohm's law, through this expression. V is equal to Ri. The symbol for resistance is R. The unit is ohm, that we often designate by the Greek symbol omega. Now, what does it mean to put resistors in series, or light bulbs in series? Something like this. So we have one light bulb, and then one end of the light bulb is connected to the other one. The other end is connected to the battery, or just continuing the circuit. We'll talk in detail later on about how to differentiate devices in general, how to identify in general if devices are in series or in parallel. But in this case, it's just one after the other. They're connected in a complete circuit. Now, the focus we are going to put is on this. And mainly what we are going to focus on, how are these two light bulbs compared to an equivalent light bulb that we can replace them by, that will draw the same energy out of the battery. Or, in other words, which light bulb can we use to replace these two that will have the same power? Okay. We'll go to the basics, the meaning of resistance. Remember, this is the equation for resistance. Rho L1 over A. So let's have two identical wires. This is one that has a resistance R1 given by the expression on top, and this is 2 given by the resistance R2 given by this expression. Now we have them the same area, same material, so the only difference is the length. Now what if we put them against each other? If we put them against each other, so our overall resistance is going to be R1 plus R2. Now look at the expression. So what's different between this and this in terms of an expression? I have a longer one. But what's the length for this? It is L1 plus L2. So these two resistors are effectively the same as this resistor, that's equal to the sum of both of them, that has the sum of the lengths. Okay. In other words, when we place two resistors in series like this, we can get the same resistance as the two of them by replacing them by a resistor whose resistance is the sum of both. In other words, R equivalent is R1 plus R2. Okay, we'll play with that in a second. So one key thing, for them to be in series, they have to be connected end to end. Only one end touches the other. Okay, let's look at it in a circuit and go back to this. This is our circuit with just one light bulb. Okay, what we are going to do is add another light bulb. I'm going to remove this resistor and place a light bulb instead. Notice here, okay, let's move them apart. Let's try to move them as far apart as we can. Notice here that the light of both light bulbs is the same. These are identical light bulbs. Now, also pay attention to the current. The current going through one has nowhere to go but go through the second one. So both light bulbs are subject to the same current when they are in series. Okay, 129, 129, 129, 129. Now, we can measure the voltage across them as well. You'll notice in this case, remember they are identical light bulbs. So the voltage across this one is 12.94. And the voltage across this one should be the same, 1294. There you got it. Now let's change one of them. And I'm going to change also the voltage here. I don't like that voltage. So instead of 25.88, let's put 30 volts. And then let's have the resistance on this one be 20 ohms and keep the other one at 10. Okay, notice now the 20 ohm resistance, okay, we can tell it to show the values. The 20 ohm resistor is producing more light than the 10 ohm resistor. Now, what's the voltage across the 20 ohm resistor? It's going to be the current. Okay, let's measure the current. It's 1 amp. It's going to be the current times the resistance. V is equal to Ri. So if I place this across it, I should find the voltage across that light bulb. 20 ohm times 1 amp, 20 volts, that's what we see. Now the power through this is going to be 20 volts VI. 20 volts times I, 1 amp. So 20 times 1 is 20 watts in this case. Let's check the other light bulb. The current, of course, is 1 amp. It's the same current throughout the circuit. In other words, the electrons, when they go through one, have nowhere to go but have to pass through the other light bulb. That's why we have the same current. Now, if the current is the same, then we have 1 amp times 10 ohms. It should be 10 volts. And there we go. That's what we see, 10 volts. So in this case, what we notice when we have two different resistors in series, they are going to be subject to the same current, but the voltage across them is going to be different. Okay? So the charge goes through one resistor, it must go through the other. So I1 is equal to I2 is I equivalent. Now the voltages are different. Now the voltage across both of them is going to be the sum of both voltages. Let's measure it here. There you go, 30 volts. That's the voltage across the first one that we measured earlier to be 20 volts, plus the voltage across the second one that we measured to be 10 volts. It's 30 volts. But the voltages are different. That's the key point. Now, the key is, what if I'm going to replace them with another resistor? what resistor should I choose? And what we said a little earlier, we have to add up the resistances. I have 20 ohm and 30 ohm. So I'm going to remove this one here. I'm going to remove it all together. And I'm going to remove this other light bulb. And replace them by one unique light bulb whose resistance is 30 ohms. So I'm going to type it up here, 30 ohms. And I should be able to get the same amount of light out. Okay, you see it's brighter than either one of them, and it should be as bright as both of them together. We can check the voltage across this light bulb, and it should be 30 volts. There you go, it's 30 volts. We can measure the current through it, and it should be 1 amp, and that's what we see, 1 amp. Let's answer this question here. Rank the expected brightness of the bulbs in the circuit shown, A, B, and C. Now we have an identical battery. That's one battery, that's the second battery. And then identical light bulbs. And the question is, which one is going to be brighter? First, since they are identical light bulbs, I'm going to have the same current. Actually, since they are in series, not because they are identical. Since they are in series, I'm going to have the same current through light bulb C than light bulb B. Now, because I have the same current, and since they are identical light bulbs, the voltage across C should be the same as the voltage across B. So they have same current, same voltage, so they should have the same power. If they have the same power, that means they are going to light up by the same amount. So B and C are going to be equal to each other. Now, how are they going to compare to A? Okay. Now, one thing that you need to remember, the voltage across B plus the voltage across C is going to be equal to the voltage across the battery. Voltage across the battery is voltage across B plus voltage across C. And remember, since they are identical, it is just twice VB or twice VC, since they are identical. In the case of this light bulb, what are we going to have? It's going to be subject to twice the voltage. If it is subject to twice the voltage, and remember, power is V squared over R. I have twice the voltage, it means it's going to have 4 times the power. So light bulb A is going to be brighter than B, which is as bright as C. Let's work this example here. We have a 10 ohm resistor, a 20 ohm resistor, and a 3 volt battery. This means that the total resistance as seen by the battery are equivalent is R1 plus R2, which is 30 ohms. Which means I can replace the circuit, 3 volts here, by a resistance of 30 ohms. Now, what's the current flowing in the circuit? So I have a 3 volt battery acting on a 30 ohm resistor. So the current is going to be, we are using Ohm's law, V is equal to Ri, and I'm solving for I. So I is equal to V over R, dividing both sides by R. In this case, it's going to be 3 volts over 30 ohm, which is the 0.1 amps here. What's the voltage across R1 and R2? V across R1 is going to be equal R1 times I, which is going to be 10 ohm times 0.1 amp, which is equal to 1 volt. I can do the same thing for R2. Voltage across R2 is R2I. So in this case, 20 ohm times 0.1 amp, or 2 volts. And you notice 1 volt plus 2 volt is equal to the 3 volts acting due to the battery.